Hi guys, in this live I'm going to be attempting to make my own Raspberry Pi firmware. So rather than using Python or MicroPython or anything else, we're actually going to write a specific UF2 file and upload it to our Raspberry Pi device. So I've got my box of Raspberry Pis here. And in here we have an RP2040 microcontroller, which simply connects to any other computer using a micro USB cable. So I'm going to rob the one from my gamepad, and I will plug that in later, and this is what will basically work. Now this is just going to be a simple firmware test. I'm just going to have it flashing an LED, and that's going to be the extent of this, but I'm basically just testing my instructions to see if they work or not. So the first thing I'll do is move this over here, split that up a bit. Most of this will take place in the command line, so let's clear my screen. So I'm going to start off with the first command, which is basically an installation of Git and some CMake libraries. So GCC, we're working with C here, so we need those compiler libraries, and we need the ARM data as well. So I'm just going to copy this, and with a Control Shift and V, I'm going to paste it in and press Enter. And I think I shouldn't have all of this installed already. Yep, that's fine. So that was nice and quick. So what I'm going to do is make a directory. So mkdir pico-firmware. Then cd pico-firmware. And I'm going to mk ledFlash. Oh, did I spell that right? Yeah, I didn't. I put MK, not mkdir. There we go. And cd ledFlash. And that's just an empty folder then. So next I'm going to make a file with touch, and it's just going to be called led. I'm going to remove the hyphen for that and just go with a capital C. I'll update my instructions here. So I'm going to use geany, sorry, to edit this file, and that will then pop it up in my GUI. I'll get rid of the untitled. Oh no, actually I won't get rid of the untitled. That's my instructions. Let's not get rid of that one. So ledFlash. We can get rid of this here. So I'm gonna. This is a very simple C program. It simply initializes a main function, sets up a contrast and UIT, assigns the LED pin to 25. It's GPIO init LED pin, and GPIO set directory, LED pin, GPIO out. So it's basically telling it to turn itself on. While true, it will basically say pin is 1. So when it's 1, it will be turned on. Then we sleep MS a quarter of a second, 250 milliseconds. And then GPIO underscore put will be LED pin 0. And then we'll sleep it for 250 milliseconds as well. So I'm just going to copy this code. And it also needs the include, so we got to include the pico / standard library.h. So I'm going to save that file now, and that's it. I don't need that open anymore. So I'll return to my instructions. The next thing we got to do is double check that file's there. Yes, it is. I'll clear my screen, and we're going to clone a GitHub repository. This brings down the SDK for the Pi Pico. So I'll just copy that and Control Shift and V to get it in there. We'll wait for this to download. Then cd Pico-SDK ls. We can see everything that's in there, and I'm just going to copy this. No, I'll just type it in, it's fine. Git sub module update init. So now we're cloning everything back into our project. So we'll just wait for this to complete. And again, as I'm waiting for this, the basic premise of this is I'll take a Raspberry Pi Pico. Well, so my desk is a bit clamped. You can see it there, the microcontroller. Rather than just putting on Python, we're actually creating a firmware to do a job using C. So that's now been finished. And we got to git module update. And then, so we go back a directory now. So we go back into our main project, do an ls, and we can see that Pico-SDK is present in the structure. We're going to copy now. Perform a copy. And then we're going to create CMake lists. So touch CMake lists.txt. And geany again, or geany. I don't know why I keep calling it greeny. It is greeny. It's geany, not greeny. CMake lists.txt. That brings it up. And we need to bring this source code in here. So it's defining the minimum make build. It's including the CMake file from Pico-SDK import. Project is flash LED project, Pico init, and add executable flash. We're adding the C file. Then we're targeting our specific libraries, and we're adding some additional outputs. So I'm going to copy this. I'm going to bring it into this file here and save. Howdy, how's everyone? Everyone's great, thank you. So that's the end of that source code. So now what I want to do is perform, actually I can get rid of this one. That's been saved. So I'm going to do a pwd, which always looks like password to me, but it actually reveals the path of the file you're going into. And then I'll need to type it out. So export Pico-SDK path equals, and this is where we need to get our path from. So slash home dc-foreman slash Pico firmware and slash LED flash, and then we need to add in a slash Pico-SDK. So type that in there, then set Pico-SDK fetch from git on. So we've got a slight syntax error there. We'll try copying it just in case somebody's typed it. Unexpected token near, right. I'll try carrying on with the instructions, see how it does. Hi Ismail. So mkdir build, cd build, probably get some errors now. Then CMake ... seems to be running. Build files cannot be regenerated correctly. CMake generate setup failed. So there's definitely something I need to do with that set there. It's possible something has changed since I last did this, which is quite common in Linux. So a command that ran before suddenly stops running. So I'm going to pay more attention to this one now and see if I can troubleshoot the error, which basically means Googling the report. Bash syntax, unexpected token. Let's see if I get a message from it. Please set. Let's have a look. SD layer was not specified. Please set or set. French. Syntax token there. SDK location not specified. That's not that. Syntax error near unexpected token. I don't think this is the same as what I'm looking for. So we'll carry on the search. Actually, it's only I've already put that in. I need to put in something more specific. Let's actually put in the report. Okay, I'll type it in. It's just easier. Example of writing bash with special beginning, comments to errors. I'll make it a bit more specific, see if it relates to my case. Right, so it's just a syntax error. So where am I going wrong with the syntax? That's the question. This was working previously, so I'm not sure why it stopped now. I'll try typing it out manually, just in case there's something being asserted when I copy and paste. So Pico, that would have been a spelling error, Pico underscore SDK underscore fetch from, there we go. Get on so is that token it's not expecting? Maybe it's because I'm in build. I'll try that again. Nope. So look what's in here. This is where I do a little bit of reading, I'm afraid. Very good one, mate. Thanks for popping by. So we got the include. I did the export. Oh, I think I need to add that to the CK list actually. It's not a command, it was something I needed to add to my source code, but I didn't notation it properly. See if it works in that location. So after that, I need to go into build and CMake ... CMake generate setup failed. Build files cannot be generated correctly. So what's the error message here? Target board is Pico, using configuration from, okay, tiny USB available, yep. Driver, yep. Configuring done. Right, so CK lists 7 add executable, so line 7 seems to be the problem. Ah, I'm being an idiot. Right, I can get rid of this. I'm being an absolute moron. Okay, so I changed the C file, didn't I? Yeah, it's not finding the right file there. That's why I'm getting errors. So I sent myself on a wild goose chase earlier when I went ahead and changed that file on the spur of the moment without updating the rest of my instructions. Right now I'm trying to build a firmware for the Raspberry Pi Pico. So this will make a UF2 file that I can just drop on there rather than using Python, which of course has the advantages that it's faster. So I can remove that one there, save that. And now I've updated the flash, the actual C file. We'll see. Now, if I just read the instructions properly the first time round, not instructions, if I'd taken the time to actually read the error, I would have saved myself a lot of trouble there. So, whoops. CD build. And then it's right, I can actually get rid of this instruction. I don't need that. And then CMake ... That's better. That's what I was expecting. Make flash LED. So now we're actually compiling the UF2 file. So it's going through everything it needs in the Pi Pico SDK kit. Chat GTP, it's like any AI, it has the potential of removing some jobs from the market. But unfortunately, that is how technology typically propels us forward. So it's out there. There's nothing you can do to put it back in the box now. It's like AI and artists. There we go. So we now have a build there. And there's our flash led.uf2. So in theory, all I should do is copy this over onto my Pi Pico. And I should, in theory, see a flashing LED as a result. So I'm going to remove my controller and plug it into my Pi Pico and get it put over there. Now to flash a Pi Pico, sorry the video is a bit dark, there's a little button named boot cell, or short for boot select. Hold it down, plug in your cable, and it will basically install itself as a flash drive. So open File Manager has just appeared on my screen. And now all I've got to do is locate that project and copy the UF2 file over. And hopefully it will start working. So I put this in... I need to go up a level. No, I don't, do I? What's going on here? Right, just going to Home. Foreman. I'm probably being black. Pico-firmware. Yeah, there we go. And build. It should be a UF2 file. Yeah. That's right there. I'm just being blind again. So I'll copy this over. That will then transfer onto my Raspberry Pi. And in theory, the light should start flashing. Oh, of course it didn't. So now I've got to go through a debugging procedure. I'm going to try another Raspberry Pi because this is the Raspberry Pi W, and I may have made this instruction set originally for the Pico Pi original board. So it's possible something's changed there. So we'll take my other one and we'll see if that one works. Same procedure, hold down, plug it in. And drag it over. There we go. So that one's working. So the reason that I need to update these instructions to work with the Raspberry Pi Pico W, but as you can see, that firmware has been uploaded to the Raspberry Pi, and it is now working. So I now need to go back, look at my instructions, and work out why it's not working for the Pi W. But I am going to quickly try copying it to another Pi W, just to make sure there wasn't something funky with that one. Always trust and verify. And we'll drag this back over. I don't expect this one to work. No. So now I know there's something different in the SDKs between the typical Pi Pico and the Pi Pico W. So I'm just going to run my experiment one more time. Now this may actually already be a dead board anyway. As you can see, all the pins, well, you can't see because the camera's too dark, but the pins are very bent. This is one I actually ran over with my office chair. So I'm going to see if it actually still has life, because it might not. Never actually tested this one. Yeah, I'm not surprised that one's not loading up at all. I need to desolder all these pins, and I think there is a slight bend in the board there, so it's entirely possible that's just a dead Pi. I'll try this one again. Recreate my success before I consider this true. So I need to hold this down, hold down, and there we go. Drag this over, and in theory we should have a flashing light when it reboots. Oh, I've picked up the wrong one again. Right, let's do it with the right one this time, shall we? I have more W's than I do old Pi's now, which is why I could see that one's working there. But we'll reset it and re-upload it just to make sure it works twice. Okay. Drag this one over. See if it's working. No. Plug it back in again. So it's definitely working that way. Maybe it didn't upload properly. Right. Open. Yes. Maybe I didn't drag it over. I wasn't concentrating. There we go. Okay, that's better. That's the reaction I wanted. So that is now. I know it's a simple turn LED off and on procedure, but this is compiled in C using the Pico-SDK. The majority of the time you'll use something like MicroPython to do something like this. It tends to be where most of the tutorials are. But this is literally just being installed as a UF2 file and then performing a task. So this is a good example of how firmware works. This module is designed to be updated, and if it's compiled in the correct way, it will simply run your source code on bare metal. So there's no interpretation layers. You don't have other language libraries on there. You literally compile your source code to be as efficient as possible to do the job that it's meant to do, and then it just doesn't do anything else. So for anyone who's wanted to know how firmware is built on a Pi Pico or other microcontrollers, then you got a pretty good idea of how it works now. And that was the point of this evening's demonstration. That will bring us to the end of this quick live. I will be doing more of these hit and run lives where I just sit down, teach something and leave. I will start announcing these in the future, so you'll know when they're going to start. And hopefully we'll get some community engagement as you come in and see me attempt to do something and then inevitably fail, fix it, and then carry on. So you get to see the whole development procedure rather than just the perfect instructions you get online where everything works fine and you don't actually have to do any of the troubleshooting process. So again, thank you for joining me this evening. I hope you've all had a fantastic Christmas, and I hope to see you again soon.